Hello and welcome to Cambridge Advanced Level Mathematics. In today's lesson, we are dealing with question 12 from paper 1 of the May-June 2023 examinations. I've tried to copy the question on the board, but I copied it in summary form because of space. And so I would recommend you to always have a copy of the examination paper under consideration so you can read the question for yourself. But I will try to describe what the question actually says. On the board here, I have got two circles, circle P and circle Q. Now, circle Q is centered at the point 0, 2. In other words, x is 0, y is 2, there. And on circle P is a tangent at point A with coordinates 6, 10. And this tangent, the green line, it passes or crosses the y-axis at point C there. And that point C is also the center of the circle Q. Circle Q intersects circle P at 2 points, point B and point C. The radius of circle P is 10. The radius of circle Q is 5 over 2 square root of 5. Let's just summarize the description again. Two circles. First circle is circle P, centered at 0, 2 with radius 10. It has a tangent at point A, which crosses the y-axis at point C. The tangent is at the point 6, 10, and then there is circle Q, centered at C, and of radius 5 over 2 square root of 5. These two circles intersect each other at 2 points. I've labeled the points B and C, the two red dots there. The first question says, write down the equation of circle P. Write down the equation of circle P. The phrase write down normally just means you don't need to have any calculations, you just quote something. Now, what do we know about circles? If we have, this would be, there is my xy axis there, x-axis and y-axis. Supposing I have a circle here and its center is there, so that its x coordinate is x1 and the y coordinate of the center of the circle is y1. The equation of the circle is given by x minus x1 all squared plus y minus y1 all squared is equal to r squared, where r is the radius of the circle. So if your circle is centered at the point x1, y1, then and its of radius r, then its equation is x minus x1 all squared plus y minus y1 all squared is equal to r squared. Now, what do we know about P, circle P? Circle P is centered at 6, 0. So x1 is equal to 6, y1, it's centered at 0, 2, I beg your pardon. It's centered at 0, 2. So x1 is equal to 0, y1 is equal to 2. So we just write down the equation. It is x minus 0 squared, which is x squared, plus y minus our y1 is equal to 2. Y minus 2 all squared is equal to, we are given that the radius of the circle is 10, so 10 squared, which is r squared, is 100. We'll just write it down. Let's copy it down here somewhere because at some point we're going to need this equation. So the equation of circle P is x squared plus y minus 2 all squared is equal to 100. That's the equation of circle P. Okay. Second question B, it says, find the equation of the tangent at P. Okay. Let's clear the board. Find the equation of the tangent at P, at A. This tangent here, the green line. Now, what do we know about the equation of a straight line? Because the tangent is a straight line. The equation of a straight line is given by y1, y minus y1, divided by x minus x1, where y1 and x1 are points that are on the line. It's equal to the gradient of the line. Let's call that gradient m. Supposing, so if we are given the gradient of a line and we are given a point through which the line passes, we can find the gradient of the line. What do we know about the tangent, the green line? Not really, but we can find the gradient there. There are two ways of approaching this. We can either find the gradient of this circle, and we know that the tangent to a curve at any point is the gradient. The gradient of a curve at any point is equal to the gradient of the tangent at that point. Let me repeat. The gradient of a curve at a given point, either here or there or there, whatever, is equal to the gradient of the tangent at that point. So in this particular case, the gradient of this circle at point A is also equal to the gradient of the tangent at point A. Let's use approach number 1 using calculus. Our equation is that one there. So we need to find dy dx. So implicit differentiation. So we have, let me expand this first of all. So it's x squared plus y squared minus 2y plus 2 squared, which is 4, is equal to 100. Simplifying, x squared plus y squared minus 2y is equal to 96 when I've taken the 4 to the other side. Differentiating term by term. This is implicit differentiation. So differentiating that, we get our 2x. Differentiating this, we get our 2y dy dx. Differentiating this, we get our 2 dy dx. Differentiating 96, we get 0 because 96 is a constant. Here it's supposed to be 4, isn't it? When we expand this, this is supposed to be 4. I beg your pardon. 4y there. So we must change this also to a 4 dy. Sorry about that. So dividing through by 2, we get our x plus y dy dx minus 2 dy dx is equal to 0. We can take the x to the other side and we get y dy dx minus 2 dy dx is equal to minus x. Let me use this side now. So we can factorize this, factor out the dy dx, we get dy dx brackets y minus 2 is equal to minus x. Dividing through by y or minus 2, we get our dy dx is equal to minus x over y minus 2. Of course, we can change this to an x over 2 minus y. I'm just trying to get rid of that negative sign there on top. So that's our dy dx. That's our gradient function. Now, what is this? What is the value of this function at point A? That will give us the gradient of the green line, the tangent at A. So at A, x is equal to 6, y is equal to 10. So we simply plug in the values there and we get 6 divided by 2 minus 10, which is equal to 6 over minus 8, which is equal to, of course, minus 3 over 4. So this is the gradient of the tangent at point A. Let's remember it. I'll clear all this stuff here. I'll clear all this. Okay. Now we have found the gradient of the line. Do we know anything else? Yes. We know where it passes through. It passes through the point 610. It has got gradient that. So we can now say y minus 10, the value of y there, divided by x minus 6 is equal to what? Minus 3 over 4, the gradient. Cross multiplying, we get 4y minus 40 is equal to minus 3x plus 18. Okay, I take the x to the side. I will have 4y plus 3x is equal to 40 plus 18 is 58. That is the equation of the line. Find the equation of the tangent. That's the equation of the line. Let's book it here somewhere. So it's 4y plus 3x is equal to 58. Okay, that answers question B. Okay, right. Now, question C says, we said there were two ways of doing that. We can, of course, use the idea of a line and in another one perpendicular to it. Supposing we draw a radius here, a line there from the center to the point A there. And what is the gradient of that line? It passes through the point 02 and it passes through the point 610. So the gradient of the line there will be, our value of y there is 10 at A. At the center here, remember it's 02, so y there is 2. So 10 minus 2 divided by 6, x here is 6, x here is 0. So divided by 6 minus 0, which is equal to 8 over 6, which is equal to 4 over 3 when I cancel through by 2. That is the gradient of this line from there. But what do we know about this line? This line is a radius, and that one there is a tangent. The radius of a circle is always is always perpendicular to the tangent. So at this point A there, we have a tangent, so the radius and the tangent, they are at 90 degrees. What do we know about perpendicular lines? When one line has got gradient m1, the other line, which is perpendicular to it, will have gradient minus 1 over m1. Let me just go through that. We have got this line, which I have drawn, the line from the center there to the point A. It's a radius of the circle. So the radius of the circle is always at right angles to the tangent at that point. So the radius here is tangent to that. The radius here will be at 90 degrees to the tangent there. The radius at this point will always be perpendicular to the tangent at that point. So this line and the tangent, they are at 90 degrees to each other. So if this line has got gradient 4 over 3, then the other one has got minus 1 over 4 over 3. So the gradient of the tangent now will be equal to minus 1 over 4 over 3. 1 over this one, the negative of 1 over this one, which of course is minus 3 over 4, as we had found. So the gradient of our tangent is minus 3 over 4. Remember how we got there. Okay? Minus 3 over 4. And we finally got the equation of the line is 4y plus 3x is equal to 58. Now question C says, find the equation of Q. My Q is not very clear. Let me make it of Q there. That's Q. That's the point Q, the circle Q. Find the equation of the circle Q and verify that the y-coordinate of the point B and C is 11. In other words, we need to calculate the y-coordinate of this point B, and of course, it's also equal to the y-coordinate of that. But first, let us find the equation of circle Q. Now, we are told that this tangent here crosses the y-axis at point C, and at that point, it's the center of circle Q. So all we have to do is, we know that on the y-axis, our x is equal to 0. So what will be y when x is equal to 0? So we have our equation there, 4y plus 3x is equal to 58. So when x is 0, 4y is equal to 58, which means y is equal to 58 over 4, which of course is 29 over 2. That is the value of y. So the circle is centered at 0, 29 over 2. That's the center of the circle Q. Question is, what is the equation of the circle? Again, we go back to what we discovered in question A, that when we have a circle centered at a certain point, we just write down the equation. In this case, it's equal to x squared, because x1 is 0, plus y minus y1, which is 29 over 2, all squared is equal to the radius we are given here, small r, which is that when we square it, 5 squared over 4 over 2 squared is 25 over 4 times root of 5 squared. Root of 5 squared, of course, is 5. So it's 25 times 5, which is 125 over 4. So we get 125 divided by 4. That's the equation of circle Q. Okay? Once again, remember, we are told this passes through the center of circle Q, and this is where the line crosses the y-axis. So when it crosses the y-axis, our x is equal to 0, we put x is equal to 0 here, we get 4y is equal to 58, y is equal to 29 over 2. So the center is 0, 29 over 2. We feed it into the standard equation of a circle. Our x1 is 0, our y1 is 29 over 2. There it is. Okay, now the second question, the second part of the question is verify that the, in other words, prove that the y coordinate of the points B and C is 11. Let's find out. Right. Where's point? There's our point B. In other words, we are being asked to solve two simultaneous equations. So equation number 1 for circle P is that one. Equation number 2 for circle Q is x squared plus y minus 29 over 2 all squared is equal to 125 divided by 4. Right, so that's equation number 2 there. We want to solve the simultaneous equations. Let me just clear this here. We can of course subtract. Let's subtract. Okay, let me call this equation number. It doesn't fit all. Put it here. I'll put it in blue. This is equation number 2. This we said was equation number 1. Let us subtract equation number 2 from equation number 1. So, of course, x minus x, it disappears. So on the left hand side, we are left with y minus 2 all squared minus brackets y minus 29 over 2 all squared is equal to, on the right hand side we have 100 minus 125 over 4, which is 100 minus 125 divided by 4. Of course, common denominator there would be 4 times 100, which is 400. 400 minus 125, 400 minus 125, which is that. So, which is equal to 275 divided by 4. That's what I'm getting here. So, this is equal to 275 divided by 4. Let's expand. This, of course, becomes y squared minus 4y plus 4 when I expand this. And let's put this in those brackets before we open it up. This becomes y squared minus 29 over 2 times 29 over 2 plus 29 over 2 is simply 29y. Then this is squared, 29 squared is equal to 841 plus 841, of course, divided by 2 squared, which is 4. I close my bracket. This is equal to 275 over 4. Right? So, are we missing anything there? No, it looks all right. So, okay, let's open our brackets here. So we have y squared minus 4y plus 4 minus y squared plus, that becomes plus now, plus 29y, this becomes minus 841 over 4. Of course, our y squared disappears there. Okay, and then let's add the y. Is this not over 4? No, it's not. Okay. 29y minus 4y gives us a 25y. Okay, then we are left with this guy and that guy. I can just call this, when I put the common denominator 4 there, it becomes a 16, 4 times 4, minus an 841, all this over 4. And I can simplify that to 841 minus 16 which is that 825. So, of course, this is equal to 275 over 4, right? So, let's simplify this part here. So, it's 25y minus, we said 841 minus 16, 16 minus 841 is minus 825 over 4. Okay, take this to that side. This implies 25y is equal to 275 plus 825 all divided by 4, of course, because this was already divided by 4. So 825 plus 275, which is that, it is equal to 100 divided by 4. Okay, now take our 20, divide everything by 4, then that becomes y. That gives us y is equal to 1100 divided by 4, of course, divided by the 25, which is equal to 11. It's like 1100 divided by 100, which is equal to 11. So we have proved that the y coordinate of these 2 points B and C is equal to 11. The question, from what I know, was worth, I think this was 3 marks, the other one was 1, the other one was 2. So it was a total of 6 marks. Thank you very much.